Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And this video today is basically a week 6 homework example here. We're going to look at the beginnings of data transfers, basic arithmetic operations. So this is just a continuation of your activity that you did earlier in the week. And but this time around, we're going to add a little bit. The first example is going to be pretty much the same as everything you did in your activity. And the second one is going to push into static cast land, where we move a value from a smaller data type like a byte and transfer that into a larger data type like a short or an int or a quad or anything those kind of things. So here is the example that I have. Yours might be slightly different, but it's the same process. So I have this in C++ and I just moved it over into a compiler because the first thing you want to know is what results am I supposed to get? So like if I start with these 8 values and I do all sorts of stuff to my code and then I print out, well, I better get 10 for my A and 7 for my B and 7 for my C, 8 for my D. So you can get a feeling for this thing, right? You can and then you can kind of work your way back and go, well, where did I go wrong? You could put these couts anywhere. You can move them and see after each line of code, am I getting the results I'm expecting to see? And so debugging or, just taking this slow, especially as you're starting out into x86 assembly language, is going to be a big deal. Because if you try to do too much at one time and there's a bug, I mean, a lot of times you'll be like, where is this bug? I mean, you're just staring at a ton of code. None of it looks like anything that you're used to seeing, and it's going to be difficult, even difficult for those people out in the field for many years. It's just because it's all you're seeing is moves and EAXs and registers and things like that. It's very easy to lose track of what's going on. Okay, so with that said, let's start moving everything over and let's start working our way through. So the 8 data types are pretty simple here. So let's see, I'm going to use lowercase a. All integer types are signed, and they're 32 bits, so they're double word. And I'm going to use 5. And let me just show you here. Let me just set this up, and let's just set up the failure here. The failure case. Let's see. So A, B, C, D, E, F, G, 5, 6, 7. Oops, 5, 6, 7, and 8. 1, up, 2. 3, 1, and 4. And the first way I go, how do I know that you didn't either watch the videos or actually write the code yourself, is if you go to build this, the way I have it, just this right here, everything it would have ran a minute ago before I put all this in here. But now if I run it or I try to compile it now, I say syntax error C. And the reason for that is that the letter C is a keyword in assembly language, or at least in MASM. And I guess it's based off the fact that, you can write assembly language that communicates in the C language, or the two languages can kind of communicate together, because at the end of the day, an object file is an object file. So you're like, well, how about I just change all of this and just add another letter, or you change the C to something else or whatever. I'm just trying to keep it consistent here. But when you do that, now I get D. And now the error isn't as easy to understand because it says missing operator in expression. And the letter DD is also a keyword. It is what we call deprecated at this point. DD does not exist, or you should never use it. That's another way. How do I know that you copy pasted? Because I never showed you how to do that, and the book doesn't really talk about it. So how about I just add a third letter? Now this is where I'm let's find out. Now A is a key. Now that's an operation. Isn't this nuts, right? So I think finally at the end of the day, if I want to do this, I can 4 of them in a row. But just to show you, there we go. Whoops, so far it's rebuilding. Uh-oh, is it doing anything? It says rebuild ... Hello? Did I kill my computer? Seriously, what's happening? Ready. Wait, did it do it? I'm so confused now. Why should the rebuild take half a year? Hello? Let's see, will it run? Yeah, I guess it'll run. I mean, it's doing something. So okay, so I'm going to use four of each of the letters to do the job that I'm trying to do. So I have my A, B, C, D, E, F, G, H, 5, 6, 7, 8, 2, 3, 1, 4. Okay, so let's get to it. So minus minus G is just going to be a decrement of G. G, 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 G. Okay, but that one's easy. Okay, so now for something like this, B equals F plus H. You're never going to want to modify the variables themselves out. The only variable in this this operation that I want to, this line of code that I want to change is B. F should not be modified. H should not be modified. So, and everything is an int. So everything can move into a full register. So I can say move into the EAX register, which is a full 32-bit register, move F into there. And then I want to add whatever's in EAX, I want to add whatever's in H. So this is the same as the EAX register equals F plus H. And then at the end of the day, now a final move back to move into B. Whatever is in the EAX register. So the register has to be part of the operation for each of these. You can't go memory to memory because of the way the buses and the architecture is set up on the x86 processor. So the CPU has to be the middleman. So you have to move information to the CPU, do stuff on with the CPU and the ALU, and then move it back. And so now it's just a matter of let's just keep on going then. So I wanted to go, okay, move whatever's in DDDD, move that into EAX register, add 22 to that, and then I want to subtract off C. Then I want to subtract off A. And then I want to move all of that into E. And so there you go. My goodness, right? It takes half a second to write this code out. It takes a lot longer to make this work. And so you can kind of see there's, for everything that you do here, I guess there's two operations that need to be performed, the equals and the plus. And to make that work, or in this case, there's an equals, a plus, a minus, and a minus, so there's 4. You have one extra line of code because you have to get the first thing onto the register. So it's basically number of operations plus 1, at least in these cases, to get the job done here. So now I have to move into the register GGGG. I'm going to negate EAX. You don't want to negate GGGG because then you're modifying G and you're not going to get the end results that you're expecting. And now I want to move that back into F. And okay, so next one is just an increment of A. That one I can do because this one is a direct modification of A. This was a direct modification of G. That's why it didn't require any extra work. But everything else, you're only modifying one thing and everything else is kind of staying the same. So let's just continue on. So let's move into EAX, FFFF, add into EAX the E, and subtract EAX 5, and then move that into G. And if I'm making any mistakes, I will find out when I go to print everything out in a couple minutes here. And so another thing is the registers are basically meant to be used as temporary holding areas. Variables are, as we've just been showing here, are a lot different. You're not meant to be modifying them just whenever you feel like it. Like, oh, how about I add one now and then I'll subtract one later? And it's like, oh my goodness, no. And plus, not on top of it just not being a good idea, it's slow because the registers are on your CPU. They're going to be much faster than doing all of these operations, going out to RAM and modifying RAM. So just so you're aware of that stuff. Okay, so getting closer here. The next item here is moving D into EAX. And then adding 19 to that. And then subtracting B from that. And then moving that into A. Okay, all right. One more to go. And now H. So I got to move C into the EAX register. And then I'm going to add A. And then you can see I'm going to add negative F. That's the same as subtracting. So if I can just I can cut my way through that one and just say, let's just subtract off F, and then put that into H. Okay, so two ways to test this. Yeah, two ways to test this, right? Let's see. It's been a while. I'm just making this video today, like just as you guys are just starting into your code. Just like I am, I'm getting back into the hang of things. Oops, there's my virus checker, just to show you guys that I have the same things happen to me. So for the moment here, I am going to disable my virus checker while I'm doing this with you guys. Only while I'm doing this. No time more. There we go. Yep. Okay, so let me see. Let me run this again. And now, yeah, virus checker is doing all this nonsense. You know, like we did all this work, but let me see. Let me add. Here, let's bring this up a little bit here. Do I have access? Let me clear this. Can I clear the watches? Can I make this easy? Clear all. And let me. I just don't know. Can I? Oh, good. So yes, one way to do this is exactly that. Just put your variables into your watch. Okay, so that shows you the values, 27, 7, 8, 18, 0, 13, 27, and I don't remember. Let me see. Let me run this here. So 27, 7, 8, 18, 0, 13, 27. So yes, I have done everything as I'm expected to here in my assembly language code. So yeah, so we're all good. And that was using the debugger, but what I can also do, and what I asked you guys to do in your homework assignment here, is to basically use the call dump regs to show that you know, or you can see what's going on here. So what I'm going to do here is it says to move into the EAX register, the A, move into the EBX register, the B, move into the ECX register, the C, move into EDX register, the D, and then call dump regs, and then do the same thing for E, F, G, and H. And then what happens when I do this is exactly what you'll see here in a second. And this pops up, and you go, it's 14, 7, 7, 8. And all I care about is the top line of each of these print statements. And you can see all the different registers. There are, 10 different registers, or 10 parts here explained and shown, and also the 6 different flags that we use. And then, so this is a good, basically a snapshot of the program and snapshot of your registers and flags at a given time. And again, coming back, let me run this one more time here, just to show you here. Here's, oops, I can't do both here. Oops, come on. Where are you? There you are. There we go. Okay, so now you can see there's this is what I'm going on here. But now you can see there's a disconnect, right? Like this is the 7 and the 7 and the 8, and then, oops, what happened to, oh, never mind. The 0 is fine, but everything else is broken, right? Or at least it feels broken. And that's because everything, when you print out in dump regs, everything is coming out in hex. And everything we printed out here in the C++ program was in decimal. So 14, you're going to have to get used to this. 14, that's 16 plus 4, that's 20. That's 7, that's 7, that's 8. Top row matches. 12, that's 18. 16 plus 2, 18. 0, B, that's 13. 1B, that is 27, because B is 11, 16 plus 11. So just so you're aware of that. Okay, so let us move on to part 2 of this problem. Okay, so I can borrow these guys because this is going to be exactly the same when I get down to the below here. And so there we go. And so now we can start working. I'm just going to start cutting my way through here, and I go G equals G plus 6. That's just the same as G plus equals 6. And that is just the same as just saying take whatever's in G and add 6 to it. If you just want to think of that's plus equals like that, there's nothing on the right-hand side at this point now, and that's what add does. Add is a plus equals operation. Subtract is a minus equals operation when it comes to the way things look over here on the assembly side. Okay, so now I'm just going to straight up put into F 16. All right. I'm going to just straight up decrement H. All right, so now I'm going to move into the EAX register 5, and then I'm going to subtract off from the EAX register. Oh yeah, let me stretch this out a little bit, right? Forgot to, sorry. Okay, so I'm going to take 5 and move it into EAX, subtract off E, and then put that into D. Okay, so then B equals minus B. That's just the same as negating B. All right, so I've done 5 operations so far. All right, so now what I can do is move G into EAX, negate it, and then I can add 11, and then I can subtract off A, and then move it into E. And just continuing on, I'm just going to nail it out, and if I made a mistake, we'll fix it later. I'm going to move D into EAX. I am going to add C to that. I'm going to subtract off A from that. And then I'm going to move it into F. All right, and the final one here, I'm going to take C, I'm going to subtract 100 from it, and I'm going to add B. So I'm just going to move into EAX register C. I'm going to subtract off from EAX 100. I'm going to add B, and then move it into C. So let's see, did I do everything right? And in this case, you probably could, since you're starting with C, you could probably just, if you wanted to, just access the memory directly. But again, this is going to be faster because everything is on the CPU, and everything is going to run a lot faster than trying every line of code there, saying, "Hey, why don't you go get me the RAM? Change RAM, change RAM, change RAM." It's not going to work right. So let me see here. Here is my. There we go. So here's my running over here for this stuff. And here is my running over here for this stuff. Oh, I do have an error. What did I do wrong? Let me see. Oh, you're probably screaming out. I just used too few characters, at least in that one case. And so far, so good. So it looks like it's working for me. I don't know why something's not right there, but that's okay. And now we're going to be looking at these guys here, right? These second ones here. And this is where the fun begins because the numbers are quite different here. So let's see. 14 in hex is 20. All right, -7. It's hard to believe that is -7 because if you add 7 to this, you end up back at 0. FFFFFF9, add 7 to 9, that's 16. That's 0. That's -7. Oop, here we go. -100. Oh my goodness, 9C, right? So if it helps you at all, you could use the calculator on this end here and say, what's 9C in X? And that is -100, like we were expecting to see right there. You can see that, okay? And now you can see F3, that better be -13, because if I add 13 to that, that gets back to 0. And so now E4, that's 16 plus 12, that's -28. And again, you can just put it right in here on the programmer side things if it helps you. Oops. Clear it out, start over, E4, there's my -28. Same thing here, let's add 2 to this thing and you get, make it E4 to E6, you get -26, so I don't even really have to do the math on that. 13, that's 19, there you go, and then this is going to be 26, so there's 26. All right, so that does everything I wanted to do for problem 1. And now the second problem I'll discuss here in a second. We're going to start doing the same kind of stuff, but we're going to work with casting now. And start with a small data type and work our way up to the bigger ones. Okay, so here's the part 2 problem. What you see is instead of just inting everything, having ints for A, B, C, and D, now you can see we have character for A, short for B, int for C, int for D. And now you can kind of see all these casts. And as you probably have realized that over the years, especially pretty much any language, when you're casting from anything to anything else, when you're changing the data type of something, it pretty much does it automatically because very rarely do you ever use the static cast, or do you ever cast in C++ or Java or anything like that. It just automatically works. It's just magic in that regard, right? So now I threw these out here for the first part of this just to, so it screams out to you that, yes, I do need to apply casting. But down here below, whatever, yes, in these cases, yes. Anytime I like C as an int, if I'm going to use A or B, yes, I'm going to have to figure out how to do some casting to make this thing work. And then, so I'll show that in a minute here. And we can also simplify this here as well. So we're not writing out every single line of code as we're expecting. So I copied over from the previous example, I copied over all these moves so we can just call the dump regs. And so you can see these are the results we're expecting to see here. 2, -5, 5, 5, and then 9, 18, -18, and 13 if we do this right. So once you've done this a few times with the static casting, there's really nothing to it here. So I'm going to take the A and I'm going to move it on over. So they say, like, I can't just say EAX comma AAAA. Here, let me show you here. What will your error be? First off, yes, I forgot about the data. So AAAA, that one is character, so that one's going to be assigned byte, and that thing's going to be a 5. BBBB, that's going to be assigned word, and that one's going to be 7. Add a space here, just CCCC, that one is going to be assigned double word, and that's going to be 11. And DDDD, that is going to also be assigned double word, if I can spell it right, and that will be 13. Okay, so now, what will come up now that these things are defined? And there you go. You can see instruction operands must be the same size. And there's a lot of errors. There's 6 of them. So we'll fix this up as we go. But the reasoning for this is AAA is a byte. Don't worry about the S part, but this is a byte. EAX is a double word. And whenever I do a move operation, I have to go from the same sized registers or variables or whatnot. So there's a mismatch. That's instructions operand must be the same size. So to get this thing from AAA like into something I can use, because I'm going from A to B, I am actually going to use AX because AX is a 16-bit register and I want to go from 8-bit to 16. But to make this work, I have to apply the move SX, the move sign extension. So the move sign extension and the move 0 extension operations allow me to have different data types of different sizes. So this allows me to take the AA, which is a byte, and then transfer it over into AX as a word, and it knows how to keep the sign going. So it'll buffer, either it'll add extra zeros or it'll add extra ones so that the value as we go from the 8-bit to the 16 is maintained. So now at least that will work. And just to fix this up, just so we can just be happy with this, the same thing goes here, where I'm just going to move sign extension. I only have to do it for these, the A and the B, because C and D are already ints, and they're all already double words. And it's funny enough that you can't, even if you do move sign extension and they're the same size, you get an error. Isn't that weird? I think it's kind of weird. So if it's the same size, you have to use move, and if they're not the same size, you have to move either sign extension or 0 extension. So I just have to fix this up 2 more times here. That should do that. Did I make a mistake anywhere else? No. So that handles everything there. So now the program will run, of course. You won't really see much. You'll see 5 in the AAA spot. That's because I got it working. But now it's just time to move on with this. So now I have to take that, and it's hard to see there, but there is a negative sign right there. So I have to negate whatever's in AX, and then I'm going to move that into the B register. And I don't have to do a sign extension or whatever because these are both the same size now. And let's see. So I should get the 2 out of this. Or did I? Or not 2. What is A? Yeah, I should get -2, right? Did I do it right? Hold on, let me see. Take A, which is 5. Oh, just -5. Duh, right? I was looking at other things. So there's my -5 because I'm not modifying B anywhere else. And there you go. If you take B, which is 11, add 5, you get 0. So yes, this is -5. So yep, I am doing things right. So now I just have to carry on doing the same kind of things that I've already been doing. So now I'm going to do a move sign extension because I'm going to take A which is a character, and I want to eventually turn it into D, which is an int. So I'm going to do a move sign extension into the entire EAX register. I'm going to move A there. There's my static cast. I'm going to subtract off from EAX my 9, and then I'm going to move that into the D variable. Let's make sure that I did everything correctly. Yep, everybody's happy. Okay, so now moving on, I can kind of just, I'm just basically just copy pasting in a way. Look at it, it's just kind of the same stuff here, but now things are going to be a little different. I'm going to move, and this is a sign extension because A is a character and C is an int. So I'm going to move into the EAX register everything that is in A. There's my cast. The sign extension says go from character to full-on double word. And then I'm going to move that into C. That's it for that. And then I'm basically doing the same thing, except this time around, I'm moving into AX because the B variable is a short, and I'm converting that into an integer. And then that's going to get moved into D. And yep, that one should not need the sign extension. Oops, oh, sorry, one extra C. And what did I do wrong here? Move sign extension B into EAX. Sorry about that. Because D, there we go, sorry about that. See, it's too easy to make mistakes. So there's my fourth problem here. D equals static cast B. B needs to go from short to double word, or from short to int, or from word to D word, and then I can move things in correctly. That should, let me see, make sure that does it. Yep. Okay. I'm not guaranteeing it's correct yet, but at least it assembles and it will run. And then the final steps, you've seen these all before. I'm just going to subtract off from whatever's in A, 3, and then I'm basically going to just, in this case, I need to say C equals, or D equals C. So I'm going to move into the EAX register C, and then I'm going to move that into D. There's no way to do that. I could try it, but you can't use two pieces of RAM in the same operation with almost any line of code. So that will give me invalid instruction operations. That's why I first set it up with the register, because you basically have to use the register as the middleman. Okay, so you take C, move it into EAX, and then take EAX and copy it into D. D equals C. Okay, so let's try this. Let's see if I get the same stuff here. And let's see, I get 2, I get -5, I get +5, I get +5. So good, part 1 is complete, and now I'm ready to kind of jump into part 2, and some of it's easy, some of it's not. So, so we're not only are we dealing with static casting here, we're dealing with a ton of operations. Let's see if we can simplify both of this before we even worry about assembly language. So let's see. At the end of the day here, the C value is supposed to come out at -18, and the D value is supposed to come out at +13. So I'm going to write that down here on a little piece of paper, just so I can just remember that. And so our goal is, can we modify this? Can we simplify this so we don't have to do all that work? Especially the second one. Oh my God, I don't want to do that. What, like the compiler is supposed to try to make our lives easier, the assembler and all that stuff. So let's see. Let's use the distributive property. Let me take this negative out and turn this into, like say, I'm going to turn positives into negatives and negatives into positives, right? That's all I'm going to, that's a positive, which is a negative. That's now a negative. This is now a negative. This is now a negative. And then this becomes a positive, and then I can basically get rid of everything and bring it in. And there is my distributive property. Turning a negative, getting rid of the parentheses and all that stuff. And then now what you see here is D minus D. What is any number minus itself? 0. Get rid of it. And what is C minus C? That is 0. Get rid of it. What is B minus B? That's 0. Get rid of it. So I am left with -A minus A is my result. Or if you want to think of it, 0 minus A minus A. So we got what we need, right? So if you want to think of this as -2A, or if so there's many ways to do this. But if I just take like this, A and A plus A, and then I negate it, I will get what I'm supposed to get, right? I'll get negative 18 out of this. Because this is a valid way to go about doing things. And so let's work with that. There's my negative 18. So let's just finish that up here before we worry about that last one. And so I can move, and so now A is a byte. Remember that as a character? So I can do a move sign extension, and I can move that into EAX. And because I want to move into the 32-bit realm here because C is meant to be an int, right? C is an int. And so I can do that, move that in there, and now I can basically add it to itself. Because if EAX is in there, that's A, and if I add whatever's in there, which is A, to itself, that's A plus A, and then it's stored in A, and then I can negate A, or I'm sorry, negate whatever's, the 2A, so I get negative 2A, and then I can move that into C. Let's make sure we get the negative 18 out of this, and then we are done. And we do not get that. What am I doing? What am I doing here? Oh, the reason I'm not getting the correct results is I jumped right ahead and I forgot to do these 4 lines of code. That's pretty easy to forget, at least on my end here. I just got excited doing the other stuff. So I'll have to move into A, a 9. I'll move into B, 18. I will move into C, a 7. And I will move into D, a 5. I want to get back into class. I do not want to be doing this sitting in my computer. I want to talk to real people about computers, not just talk to a computer about computers. It's not as much fun. And so, okay, so A is 9, B is 18, C is 7, D is 5, and then I do my work here. And on top of all that, I moved the print statement. I'd like to say I'm doing all this on purpose, but I'm doing this all because I am rusty and it's October, fall. My kid was very sad to see that summer was ended. No more going to the pool, no more running around. Now it's going to start getting a little chilly, but then fall's nice too. He needs to put on a sweater. He doesn't know that yet. He's 5 or 6 now. Okay, so coming back here. Okay, so now what do I get again? When I'm comparing the two here, my A is 9, there's my A. My B is 18, there's my 12, which is 18. There's negative 18. So E, that's a negative 16 plus, plus another 12. Or wait, no, plus 2. Or coming back, where's my calculator? Oh, I got rid of my calculator. Let's bring it back in. EE. Oops, let's put it in hex mode. EE in byte mode is negative 18. Fair enough there. And then D we haven't worked out yet. We haven't fixed, but you can see it'll probably be a little easier this time around. But that's why I gave you less to do on this one, because the math gets to be a little tricky with all the castings and all the things that we're doing. Okay, so let's take a look now. So let's just kind of work down what we can. Here's a positive B. There's a negative B. That's a 0. So now let's see, I have a negative C, and I have a positive C. I have a negative D. I have a positive D. I have a negative A. I have a positive A. Let's see, that is a positive B, so we can leave it. Let's see, I have a positive C, and you can see here there's a negative C. So I can get rid of both of those. I see a negative A and a negative A. Okay, oh boy. Okay. So that might be it. Let's see, do I get my 13? Did I do something wrong? Let me see what I get. Nope, I still get 13 out of this. So I don't think there's anything left I can do. Because there's B plus B. Nope, that's 2 B's. Minus D, there's no other D's. And then 2 A's here. Minus A, minus A. So there we go. So now we're going to have to go ahead and figure out a way to convert this. Okay, so the first thing I'm going to do is take B and copy it into a register. At the end of the day, D is what I'm going to be putting everything into, so I'm going to move up and just move sign extension into the full EAX register with whatever B is. And then I can subtract off D from that. That's the easy part. But now the final thing here is to subtract off A twice. So I don't want to blow out anything. So I can use a different register, and I'm going to move A in there, and I'm going to do a sign extension because I'm going from byte to double word. And then now I can take and I can subtract off whatever's in EAX, and I say, okay, take whatever's in EBX, which is the A stuff, and subtract it. And I can do that twice. And then, at the end of the day now, I can do the same kind of thing with B. Maybe I should have doubled it up earlier, but I didn't do that. So what I can do here is I can just do this one more time, move sign extension into EBX, B, add that in to whatever's in EAX, and now, at the end of the day, move that into D. I never said this is the only way to do it. I just said that this is a way to do it. And now, do I get positive 13? Or does this even work? Let's see. What did I do wrong? Nothing. And what do I get out of this thing? I get, oops, I did the same thing where you're probably screaming at me. I am adult. I am having a night tonight, but I'm not redoing this video. And I'm going to do the work and then call the function basically to call the dump regs. And I do not get the right answer. I get D. No, that's 13. I get the right answer. D is 13, and I am correct in my assumption here. And I did everything properly using a combination of basically moves and move sign extensions and subtractions and additions, and basically the only four of the 5 things. Negation, no, there's 6, right? Increment, no, 7. Increment, decrement, negation, add, subtract, move, and move sign extension. So those are the 7 operations that we're going to start out with for this program. So if this second part was confusing to you, everything static casting, then thank goodness it's done. I'm not going to make you do any more static casting. As we get more knowledgeable and as we discuss more and more things, you will see that I'll just be using basically one data type for everything. But this is just to show you how to do the casting, how to move your way from type A to type B, or type T to type U, or whatever it is that you're trying to talk about here. Okay, so that covers everything I wanted to talk about in this video, and especially in this video, since I'm being a dunderhead today. If I misspoke about anything and I said something wrong and I did something differently than what I said, or whatever, or if you just have questions or anything at all, please contact me down below here in comments or at swardb@cod.edu, and I'll get back to you as quickly as I can. And so this basically is just, the start of everything. We're going to start moving into other operations and arrays, and we're going to be dealing with different math, multiplication, division, loop structures, if statements, and all of that jazz, and function calls. Everything up to pretty much any standard textbook for any high-level language. We're going to be dealing with basically up to chapter 7. Seems like chapter 7 is like universally like arrays for the most part. So basically everything up to arrays is fair game in this course. And but we're starting, it's week 6 here. We're starting small. We got 10 more weeks to get ourselves from what you see here up to everything up to chapter 7. So thanks for sticking it out with me as always. Hope to see you guys in another video. Hope you guys deal with everything I got for you here. Have a great day. Talk to you later. Have a great one. See you then.